Hi, my name is Mike. I work for McCampbell Analytical. Today we're going to be going over a video that will show you how to use our Helium Shroud during soil gas sampling. Alright, let's go ahead and get started. Alright, first off, what I want to show is just the parts that we're going to be including in our shroud assembly before we do any setup or anything like that. First off, we have this box, which kind of represents the shroud itself. It's got various ports and valves that we'll go over in just a few clips here. Here we have some cork stabilizers that help to keep the shroud stable on the uneven ground while you're sampling. Over here we have our gas helium supply with regulators. We have a purge can. It's been evacuated prior to giving you the shroud. For this setup, we have two sample cans here. Also over here, we're going to have a helium analyzer for real-time analysis of helium in the shroud. We have a sampling pump. We have a 9/16 wrench, a syringe here, and of course the manifold itself that we'll be using for sampling. Along with some various tubing, that pretty much makes up the helium shroud assembly. And so I guess right now we'll go on and show you how to assemble everything. Alright, we're here for the second step of our video. We're going to go ahead and assemble the shroud over the well in this step. First thing what we're going to do here is we have a well in the parking lot. We're going to go ahead and pull out the sampling line and place our stabilizer around the shroud itself. Pull the sampling line up and just grab another stabilizer to get the other side here and place it right there. So now we have a nice stable surface to work with. Next step will be to install the manifold. There's two parts. We're going to install this side to the purge port over here. And this side we're going to be installing to the borehole test port for our optional borehole integrity test, which we will go over later. And down, the 9/16 wrench will be used to snug up those fittings. Okay, nice firm. Next step is to add the sampling cans to the manifold. This can will go here. This is our primary sampling port. This is our secondary port, which can be used for a second sampling. Go ahead and install that like so. And then we're going to go ahead and attach our actual sampling line from the bottom of the well right here to this valve. Snug that up as well. Alright. Now the manifold is pretty much in place. What we're going to do is hook in all the external purge cans and helium supply. So we'll grab our purge can here. Go ahead and install this to our purge port, which is located right here. There's labels throughout the inside of the shroud that guide you along as you're installing these things. This is our helium supply, and it's attached right here to this port. Just a few more things here. On this side we have our helium analyzer. You're going to want to install this on the lower port of the shroud. And the final step is our purge pump, which will go here on the upper port. And you just slip the tubing inside the outer tube on the pump itself. Alright, final step. To add our lid, go ahead and put the plastic around the outside of it. You want to make sure to leave yourself a lot of space to work with. Close it up. You do want to connect this right here. Alright, now that's a complete installation of the shroud on top of the well. The next step will be to go ahead and purge the shroud with helium. Alright, we're here for the third step of the video. What we're going to do is create a 20% helium to air atmosphere here inside of the shroud. As you well know, the reason we're doing that is so that we can use helium as a leak check compound for our soil gas sample. To do this though, I'm going to take the lid off so that you can see what's going on the internals here. Go ahead and put this off to the side. So the first thing that we're going to do is turn on our helium supply. We have a valve here. Basically it's a three-way valve. There's a full blast position, there's an off, and then there's a purge position that we have a flow restrictor installed that will purge the shroud at a specified flow rate. First step is to turn off the valve. We're going to go ahead and turn on our helium supply over here. We have a regulator, this black one right here. This should be set to 10 psi for this flow restrictor to provide the correct flow rate. That's also going to be accompanied by this pump pulling out. So the first thing that we'll do is kind of blast the shroud with some helium by turning the valve in this direction. As you can hear, it comes out quite quickly, so you'll only want to do that for maybe 5 to 10 seconds, and then you're going to go ahead and turn it to this other position, which will begin a slow purge of helium throughout the shroud here. So the next step will be to turn on this sampling pump that we've hooked up to the opposing side, and again it's set at a flow rate so that we can achieve our 20% atmosphere inside the shroud itself. So that's on. It's just a little switch right there, and basically it's going right now. It takes approximately 10 minutes in our tests to reach this 20% atmosphere, which is very stable within 1% according to our analyzer here. So what we'll do is we'll just step away and let it do its work about 10 minutes, and we'll come back to it and check our helium concentration. Okay, so the shroud's been purging for about 10 minutes. What we'll do here is we'll go to our helium analyzer. You can turn it on. Has a very easy to read display. It only displays oxygen and helium. It's pretty hard to go wrong with it. The operation for this guy will be to simply just install the syringe right at the end of this tube and give a quick pull, just like that. You'll go ahead and check the reading on the analyzer, and as I can see right now, it is about 21%, which is sufficient for us. You can go ahead and check it again if you like, just to be sure. And again, it's just a quick pull like that. You want to get a rapid flow rate through this sensor here to make sure your reading is accurate. So that's why you want to kind of give it a quick tug. But yeah, again, it's 21%, which is going to be good for our sampling. And we can go ahead and monitor that throughout the course of sampling if we'd like. And that's about it. Okay, we're back. We're here for step 4 of the video. This part of the video, we're going to be going over the borehole integrity testing, the shut-in testing, and the well purge. The first thing we're going to do is the well purge, and what we're going to be doing in that test is determining the sampling volume that we're going to want to collect. So the way it's done is we're going to use the 60 ml syringe that we've supplied, and we're going to pull on it, and as soon as we feel a resistance on the plunger, that we'll take note of the volume, and we'll use that to determine the amount of volume we're going to actually sample. The DTSC recommends we do 3 times that volume that we'll determine with a syringe. So let's go ahead and get started. The first thing we're going to do is take this valve on our manifold and go ahead and turn it in this direction so that the arrow is pointing towards this connection here. And that will allow us to sample from the well with our syringe, basically going down through here like this. So we'll go ahead and just hook up the syringe like this and just begin pulling. And you're going to want to pull, pull, pull until you feel a tug on the plunger, and it slows. And as we're seeing here on our well, it's coming out at about 46 mils. So that will be, you know, varying based on your well depth and whatnot, but we're going to use 46 mils as our guideline for sampling volume. Okay, so once that's done, we're going to go ahead and close this valve here. Okay, so for the next step in the sequence here, we're going to be checking for the low soil permeability. The DTSC recommends that, you know, we're going to have a vacuum here that's no greater than 7.35 inches of mercury shown on this gauge while we're pulling a sample. Also, we need to make sure that we have a flow rate that's greater than 100 mils a minute. So to do that, the first step is to just evacuate our manifold here. We'll do that by opening up the can and then opening this valve right here to create a vacuum. What we like to do at McCampbell, just to make sure that this connection here is free of leaks, is to do a kind of variation of a shut-in test where we'll just close the purge can and look for a gross drop in vacuum here. We would recommend probably about 5 inches of mercury over the course of 10 seconds, a very large leak, to make sure that the flow, when we're checking our soil permeability, is correct. So what we'll do is just turn off the can once that this is built. So the can is off, and we're going to monitor this gauge right here for a drop in pressure. This is definitely sufficient. You don't see any visible movement on the gauge, and that's going to be fine for this particular test. So we'll reopen it. And now we're ready to start the soil permeability testing. So what we'll do is open this valve in this direction with the arrow pointing towards the manifold, and then we'll begin sampling of the well. Okay, you can see here that the gauge is reading 0. That is definitely within an acceptable limit. Again, it should be below the 7.35 inches of mercury. And on our rhodometer, we see that we're flowing up well over 100 mils a minute, which is going to be acceptable as well. So the soil permeability for this particular well would be just okay for sampling. And so now we'll go ahead and turn off this particular valve. Turn off this valve as well. All right, we're here for the final segment of this step. This is going to be the shut-in test, and we're also going to proceed with the optional borehole integrity test, just so that you're familiar with the procedures. So this test is testing the manifold for leaks. That's the basic gist of it. And what we're going to be doing is watching for a delta drop of pressure here, which would be just absolutely, you're looking for no needle movement at all over the course of a minute to ensure that we have a nice tight manifold. So, okay, so the first step that we'll do again is just to open up our purge can and open this valve here to recreate a vacuum inside the manifold. You're going to go ahead and see they're already there. Everything looks good. So, that looks great. So the next step here will be to go ahead and hook up our helium meter to the borehole port. This is the optional test that I was talking about, and what we're going to be doing here is looking for helium intrusion into the bottom of the well. And we can go ahead and do this simultaneously as we're doing our shut-in test. So to do that, we're going to take this valve here, we're going to make sure that it's turned in this position so that we can sample from the well. It also will still keep the manifold in a tight position so that we can do our shut-in test. So to begin, we'll just turn this valve to the off position. We've locked in our manifold, and we're going to look for a drop in pressure on this gauge. There should be no visible movement over the course of a minute. So okay, while that's going, we hooked up our helium meter here to this port, and now what we're going to do is just take a few samples from the well, looking for any helium that may have encroached to the bottom during our process of purging. And that would, basically show that you have a not tight borehole seal, and you may need to reevaluate your sampling because you're going to have an invalid leak check compound present in your samples. So what we'll do is just pull some sample through the meter with the syringe. So this is coming up from the bottom of the well and into our meter. And then what we're looking for here is a less than 1% of helium reading. Any greater than that and you would be out of spec for this procedure. So our readings are good. We have 0 helium at the bottom of our well. Our borehole integrity test has been going, our shut-in test has been going for about a minute, and we have absolutely no movement on the needle. That means that our manifold is tight, we have no leaks, and we're ready to proceed with sampling. Okay, finally we're ready to sample. We've gone through all the necessary steps that need to happen prior to sampling. So what we can see, we still have a vacuum in our manifold from the shut-in test, and it's pretty simple to start the sampling process. What we'll do is you need to turn on this valve, and you also need to turn on the valve opening up the sample can there. So again, this valve is off, and I have this valve off as well because we're not going to be collecting a secondary sample for this video right now. I just have this here so you can see it. So I'll show you. Basically what we'll do is turn these pretty much simultaneously, and we'll go ahead and do it right now. There we go. So we're actually collecting a sample. You can see there's very little vacuum, so we're within specs for our restrictions at the bottom of the well. And we can see here the vacuum is pulling. As you probably know, you're going to collect samples till the pressure here gets down to -5 inches of mercury, which would indicate that your sample can is pretty much full, and you can go ahead and finish off sampling. So right now we'll just let it go. Alright, we've been sampling for about 6-7 minutes or so. We can see this gauge here is below the -5 inches of mercury, indicating our sampling is done. First thing you want to do is just go ahead and shut the sample can. Very important. Close that sample off and go ahead and turn off the well as well. And that's it. We've basically collected a sample in this can. You can go ahead and remove it from the manifold and turn it into McCampbell for analysis. So we've finished everything. We've collected a sample. The shroud is ready to be disassembled and moved on to the next location. One thing to note, everything provided can be reused except for the sampling manifold and your sampling cans. Obviously they've been contaminated with the sampling that you've just done, and those will be provided to you for however many samples that you're looking to take. But everything else, the purge can, as long as you have enough vacuum, the helium supply and everything should be able to be moved on to your next stage of sampling. And that will conclude our video for the helium shroud. I hope you enjoyed it.